All right, so let's take a look at some of these examples here. On number 5 and 6, they ask you to use the leading coefficient test to determine the end behavior of the graph. And so one thing you need to make sure before you start using the leading coefficient test is make sure you're in standard form. And this is in standard form. And so one thing that you need to check is, are the exponents descending from high to low on all your variables? And they are, right? So over here I have an exponent of 7, of 5, and this exponent right here technically is a 0. Okay, so it's in standard form, and that way you can identify the leading coefficient, which is -7. The degree of the polynomial is the highest exponent, right? And so this number right here is odd. And so if a sub n, which is -7, is less than 0, and the degree is odd, right? This has the same end behavior as f of x is equal to -x cubed, right? And if you could visualize what -x cubed looks like, it looks something like this. In plain English, the end behavior is rise on the left and fall on the right. Okay, now using the leading coefficient test will give you the end behavior right away. It'll help you sketch. But remember, on the pre-calc AP exam, you have to understand limit notation. Okay, so let's practice this. Rising on the left would, the way I would write that is the limit as x approaches -infinity, f of x, which is the y value, goes to +infinity. And then falling on the right, I would say the limit as x approaches +infinity, because it's falling, right, f of x approaches -infinity. And that's how you write fall on the right. All right, so for example, problem number 6, notice this problem is not in standard form, right? The exponents are not descending from high to low. So if I were to rewrite this, this would be +2/3 x to the 21st, -2/3 x to the 11th, right? And if I distribute to that last one, it's or the first term right here is +2/3 x to the 4th. Now you're in standard form. Remember, the exponents have to descend from high to low, going from left to right. Okay, so again, if I ask you, hey, what's the leading coefficient? You would say it's 2/3. I only care that it's positive. The degree or n of the polynomial, which is the highest exponent, is 21, which is odd. Right, and so using the leading coefficient test, using these two pieces of information, this has the same end behavior as +x cubed, right? And +x cubed, if you could visualize in your head, right, falls on the left, rise on the right. Okay, so fall on the left, rise on the right, in plain English, and then in limit notation, you would say the limit as x approaches -infinity, f of x approaches -infinity, and the limit as x approaches +infinity, right? The y value, if it rises on the right, it goes to +infinity. All right, so that's all you're doing for the leading coefficient test. Again, just really get used to the limit notation. All right, so moving on, I'm going to do number 7 and number 10. So on these problems, they want you to find the zeros and then determine the multiplicity of the zeros. All right. So again, finding the zeros, right, just means finding the x-intercepts, finding the roots, finding the solutions. Basically, I set g of x is equal to 0. And then it looks like I have a greatest common factor here. Okay. And that greatest common factor of all these three terms is simply -2x squared. So what's left inside is an x squared minus 10x plus 25. You can factor this even further, right? This is a perfect square trinomial, and you can't factor this any further, okay? So again, using your zero product rule, if you do this in your head, one of the zeros that you're going to get from this, right, is simply 0. If you set this equal to 0 and solve in your head, you're going to get x is equal to 5, okay? All right, so the concept that or the new concept that you may not have learned before is the multiplicity. Remember, the multiplicity is just the exponent, right? How many times does the 0 occur? So for this particular 0 of 5, the multiplicity is 2. And then for this multiplicity of 0, right, I look at the exponent, that multiplicity is also 2, okay? And that's it. Make sure you are able to factor it. Make sure these are linear factors, and then you simply look at the exponent. All right, so moving on to the last problem, number 10. Again, 8 and 9 will be posted on Canvas if you need additional examples. Again, to find the zeros, right, I set the exponent, or I set f(x) equal to 0. It looks like I do have a greatest common factor. In this case, I have x to the 4th as my GCF. And what's left inside is a 3x squared minus 1x minus 20. And then remember, you have to factor this trinomial. 3x times x will give me 3x squared, and then factors of 20. You can list them all out. I like to teach factoring by guess and check, 2 and 10, 4 and 5, or again, you can use the opposite order, right? 10, 2, 5 and 4 instead of 4 and 5. And over here, I'm going to just simply write plus 4 minus 5. And I'm going to check to see if I FOIL this correctly. Or factor this correctly by FOILing it. That's 4x, that's negative 15x. 4x minus 15x, it equals negative 11x, which is this middle term right here. Okay, so I factored it correctly, right? Once you factor correctly, you can now find the zeros. So over here, don't forget this 0. You're going to get a 0, 0. On this one right here, if you do a little bit more correct, we do this, we set this equal to 0. Maybe it might be a little bit more difficult to do in our head. You're going to get negative 4/3. That's another 0. And then this one, you could do that one in your head, right? That one, you're just going to get x is equal to 5, okay? So again, the new concept, right, of multiplicity, the exponent for this 0 right here, on my previous function, in previous line of work, the multiplicity in this case is 4. That means that 0, 0 occurs 4 times. For this 0 of negative 4/3, I look at the exponent right here, that's just 1, so that multiplicity is 1. And then for this 0 right here of 5, I look at the exponent, the multiplicity is all 1. All right, so if you need additional examples, you could look at numbers 8 and 9, but that's it in terms of leading coefficient tests and finding the multiplicity.